Hello, this is the next video in a series that I'm calling Transformations of Random Variables. Today we're going to take a variable t, which is t distribution, and we're going to map it or transform it into a beta random variable. And so let's let t be a t distribution with r degrees of freedom, which means this is the density for it. And we're going to let y equal this transformation, 1 over 1 plus t squared over r. Now, you can note that this is not a one-to-one function because it maps two elements, to one item over here. So if you put a positive and a negative number, it gets mapped to the same thing, which is still a function. It just means that you can't, it's not a one-to-one, it's not a function going the other way. And so we're going to have to break this into two regions where both of those regions that this function would be a one-to-one function. Our goal, of course, is to find the density of y. So let's break it into two regions, 0 to minus infinity and 0 to positive infinity. And let's work over both of those regions. So if we take this and back solve it for for t, we get this. And I just say T1 because that means we're over this region here. We expect to get a negative number for t, right? So that's why the negative is out front. And when we're over region 2, this is the region. So it's the same thing, but when you end up taking the square root to get rid of the squared, then you have to say plus or minus, and that's why it's broken into two different regions. So let's take the derivative of both, and we get this. And now to find the density, it's f of y is equal to I guess it would be f of t. So it would be f of t over this region, and f of t over region 2, that's what the 2 is. And then you plug in what you back solve for. So this is actually this value here. So you plug in this for right there. So we plug in T1, and then we plug in T2, which is this up here, into our density. And this density, the t density, is this. And then you take it times the absolute value of these derivatives in the respective regions. And since each of these regions here are mapped to the same region, then we add it when we trying to find the distribution of y. Okay? And sorry about this confusion here. It should be T1 and T2. Or you could just say T where we're over, this specific region. So now when you plug in the information, so this information into the t distribution, which means plug it in right here, so since this is all square root, when you plug it into the squared, it goes away. That's what we get here. And then times the absolute value of this derivative here. And that's what's on top. Then we have to add it, do the same thing over here. Well, if you look very closely, they look exactly the same. This is exactly the same as that. And there's a 1/2 here and a 1/2 here. So you can kind of pull it out front and say it's 1/2 times this plus 1/2 times the same of that. So when you add them together, you get a whole. So it's like taking away this 1/2. Or you could think of, you factor everything out except for that half, and you're left with 1/2 plus 1/2, which anyway, you get just this distribution back. Now it becomes algebra. So now we need to simplify. So we can, combine this to 1 minus y over y, and then you combine that and you end up with 1 over y. You combine that. So that's the next steps here. So, you also get a cancellation. So this 1/2 r, square root of r, square root of r, and we're left with this. Now we invert and multiply, and this right here, you invert and multiply, you know, and so this comes down. I changed the square root of pi to the gamma 1/2, and you end up with this. So remember this 1 minus y, you take it down and it becomes a square root, but when you bring it back up, you get minus 1/2, you know, and that's what this is. Now these can combine to this, and again, this is from 0 to 1, and this right here is a beta distribution, beta of 1/2 r and 1/2. And so we transformed a t distribution into a beta distribution. Well, I hope you enjoyed this. I sure did. Please like it if you did, and subscribe so you don't miss the next one. Thanks. Bye.